Airtime fairness is a software scheduling feature on the Ruckus access points that's responsible for increasing overall network capacity. The reason it's needed is that without some smart scheduling, there will be a natural tendency for the clients that are further away or otherwise having a poorer performance to monopolize the airtime and drag down the overall capacity of the LAN. The reason for that is that different physical layer data rates take much different lengths of time to transmit the full-size packets. If you have a client that's further away using say a 1 megabit rate, his packets can take 10 milliseconds, for example, to transmit. Whereas clients that are nearby using a very fast physical layer data rate can take hundreds of microseconds. So a huge difference between the amount of time taken to transmit to a very strong signaled client versus one that's further away. So if you have a mix of clients, some near, some far away, the natural effect will be that the further away clients will tend to monopolize the airtime. Their packets will be taking much longer to transmit, and then you'll go to someone who's close and he'll get a little slice of the time, and then back to someone who's further away who will then take a disproportionate amount of time. So really, without some sort of smart scheduling, the natural tendency is for the overall capacity of the LAN to drop down dramatically due to the further clients monopolizing airtime unfairly. Ruckus access points all implement a software-based scheduler which decides which packet to send to which station at any given time. Many access points actually rely on the hardware, the chipset, to do the scheduling and select which packet to transmit, which leads to a lot of non-optimal situations because the hardware doesn't have as much visibility into the overall link conditions and the number of active stations as software potentially does. So having this software-based scheduler gives us the ability to implement some very clever scheduling algorithms such as airtime fairness. With airtime fairness, it's actually fairly simple to implement because you just have to keep track of the amount of airtime that you want to allocate to different clients. And we move from one client to the next, letting each of them transmit some number of packets such that the airtime is equivalent between the stations. Instead of sending one packet to one station and then moving on and sending another packet to the next station, we'll send a group of packets to a station such that the airtime it uses is equivalent. Say, for example, 10 milliseconds before moving on to the next station and then allowing it to transmit also 10 milliseconds worth of traffic. The expected results are overall increase in throughput or capacity for the wireless LAN. Specifically, how that should show up is that the stations who are nearby, the ones who have a very good physical layer data rate, will be able to burst a lot more frames into their allotted time slot, and thus the overall capacity of the wireless LAN is increased. So let's look at some real-world results that illustrate this effect. The before slide shows the throughput of two stations before airtime fairness was enabled. As you can see, both of the stations are getting approximately equal throughput. This is because the scheduler is round-robining between them, and the slower station is dragging down the performance of everyone. The after slide shows the results once airtime fairness is enabled. And here you see that the station that's 11N and capable of doing a lot higher throughput is actually able to achieve that. And so overall, the capacity of the LAN is increased.